Hi, and welcome to the sixth video in the series about optimization in UEFN. In this video, we will look into textures and how they contribute into project download and upload sizes. So I have here few clips and rocks. They are provided for free Rural Australia pack. It's created a few years ago. So I took this just because they have pretty large textures and to demonstrate how we can optimize that and how quickly they can uh, create problems with a project size. So I already pushed and you can see my project size, it's 13%. And most of that, it's a textures. And I only have these two clips, two, and then I have two pieces in here. And that's it, it's empty project. So first of all, let's cover textures and how we seeing that all these measurements. I'm not sure how about you, but this refresh never worked for me. So I would recommend if you want to see real updates of the project size. And by the way, this is showing this upload size, 13%. So to see a real update, just push changes to Fortnite map. And then it automatically refreshes properly. It's kind of like forcing to refresh because with this one, I never had success. And of course, like I have static mesh on a second place because these rocks, they not so high poly, but still, because this is AsicsoN, so nothing else contributing. So mainly just static mesh and texture. To see exactly what textures and what meshes it's calculated there, you can go in setting, I buy package, and straight away we can see what we have in there. So it's really handy. So then we can see like, okay, this is almost 5 megabytes, one texture. You can right click and browse there. And this is our texture. We can open it. And straight away what we can see is that it's a 2K texture. And yeah, it's a 5.5 megabyte in here. So sometimes 2K is fine. So don't forget 2K, 2048 by 2048. So we're always calling it 2K. This is maximum resolution allowed in UEFN. If you will have it's larger, UEFN will start crying, and you can always reduce that. And we have a few parameters in here. So first of all, so I want to point out that textures, they're not contributing into memory usage in here because here it's a RAM. Textures going into VRAM. So they going into GPU memory. And that's why if level have lots and lots of high resolution textures, you will have issues as well if someone's video card, graphic card, it has not enough basically VRAM. And eventually what is happening, we can start to see some rainbow effect, some artifacts on the meshes. It's basically because of the textures and some other stuff like flickering and even crashes. And again, keep in mind that Fortnite platform is cross-platform, so mobile devices has a much lower amount of VRAM than high-end PC. So you need to be careful on that as well. So it's good that they're not contributing because, like, as we can see, they can be pretty heavy, right? But you can see that availability is GPU. That's basically it's like it's done only on the GPU side. For the safety measure, what I like to do, and if I'm, for example, optimizing textures, for me to tell which texture I already tried to optimize and it's fine, I'm just changing this into stretch to power of 2. Because it was 2048 by 2048, it was already power of 2. It won't do anything. But then next time when I will open this texture, I will see that, okay, I said this. It means I already optimized this texture. So it's basically more flag for me. Then we have maximum texture size. And then we have meep maps and streaming, right? So I'm always telling to people, don't use this never stream, okay? Because this is meant to be only for UI. When on UI elements, they always closest to the camera because they're on the screen. And this is for stuff which like meep maps and streaming. It's for the stuff when you're trying to load too many stuff at once. So it's imagine that this is a pipe, right? And you're trying to push through that pipe certain amount of water. It doesn't matter how much you will push, this pipe will basically explode or block, I don't know, but it won't go more, right? So this is basically stream, and that's where streaming is about. So for example, if you're loading, I don't know, hundreds of textures, high resolution texture, let's say 2K, your GPU can't load all of them at once. It's impossible, right? And that's where artifacts and all this kind of stuff happening. What streaming does is basically it calculates what stuff it's less important, maybe what stuff it's really far away from the camera. So then load in that streaming because of the meep maps, and we see like it's 12 meep maps. And by the way, what meep maps means, it's what we covered in the first video, LODs. This is LODs for the textures. It's basically takes your highest resolution, let's say it's LOD 0, so it's meep map 0, and then it duplicates many times, and then it's every time it's cut it in half. So for example, you can preview it here, see? So we now on meep map 0, so 1, see, it's 1K, then it's 512, right? Then it's 256, and it goes up to like 1 pixel probably. And what it does, and we don't control that, it's automatically, and what it does is basically further away from your camera will be mesh with this material and texture. It will basically will swap into, based on this distance, into certain LOD on this meep map, right? If it's super far away, this texture will be like maybe 1 or 2 pixels, right? If it will be closer, then it's 8, 64, yeah, 256, and it's getting that. And same for loading. When this object is far away from your starting location, then it doesn't need to load 2K texture on that mesh, right? It can load 8, and that's it. Problem happens when, for example, your object, it's far away. For example, it's a planet, but it's a huge planet. So it's visible from the start location straight away. But GPU don't care about size. It will think, okay, this object, for example, this sphere with the texture of the planet, it's 1,000 kilometers away, right? So I don't need load with a meep map 0. I will load with a meep map 10, right? And that's where we see maybe for 1 minute this really blurry this object, and then after 1 minute, because everything else is already loaded, so then it loads that as well, sphere. So that's a thing. So sometimes you won't disable then streaming because you know that you can handle that because object is far away, but you want that texture always be loaded. But if your object is really not visible, don't do this, right? Because if you're saying that my texture really looks blurry, so I need to disable this streaming, it's not because of the streaming. It's because you have too many textures and they load it out once. So basically, just look, maybe somewhere else you can do more optimization on the texture and maybe not load everything at once. Load just by pieces, maybe by using data layers, yes, streaming. All these techniques, they allows us to work with these meep maps. So streaming, it's important. But it's as well important to understand that in UI, we don't need any meep maps because it's adds It's a little bit, but it adds to size of the texture, because we're creating again 12 copies. Yes, most of them really tiny, but some of them still. For example, if I have 2K, there is a 1K and 512, right? So it's at least at like 1 or 2 megabytes on top of that. So for example, if I will set it to no MIP maps, you see now I've got 4 megabytes. If I'm putting it back, I don't remember what it was, sharpness 3, you see? It basically adds 1.4 megabytes just because of the MIP maps. But they need it, they're helpful. But we don't need MIP maps on UI, because UI never far away from our camera. It's always on the screen. And I'm talking not about this text in the world, I'm talking about on the screen in UI. So it's one thing. Another thing, what I see people doing, and again, pay attention this stuff. So by default, when you're loading, it's default, right? So sometimes it may detect this texture as a normal map. So normal map can add details, fake details to the surface, but most of the time is default one. And if you have some issues with the texture, most likely it because you had a little bit more this color. Yeah, so this is pretty much how normal map looks. So then when you're importing this texture, UEFN may think, oh yeah, this is normal map, and change this compression to normal map. And because normal map render it differently, it will basically screw up your texture. So if you have issues with texture, just make sure that this is default and sRGB. Maybe it's not sRGB, but most of the textures now are sRGB, right? So pay attention to that. And so we have default one, and then people think, okay, I will set it to user interface. So look on the top, we have texture size is almost 5.5 megabytes. Now user interface, and we have 21,000. So it's basically 21 megabyte, almost 22. So you see, compression, it's super important. And you don't need to set, even if it's UI, right? Even if it's UI, you don't need to set here into this interface. So set it to default, set it to 5.4 megabytes. But then in here in texture group, you can go to world and you can set to UI. Okay. So if you will set this to UI, you can set never stream, and you can set no MIP maps manually like that. And it shouldn't throw you warning error about that. Okay. And because of all that, so it will reduce again this memory, not memory, it's in project size. And of course, like if something won't work, so last resort, it's again, yeah, it's basically changed this to user interface. But you saw it adds a lot to the size. So back in here, we have two last things. So LOD bias, and we have maximum texture size. They're pretty much same, almost same. So if you have like maximum texture size, it works always. LOD bias, it works only if you have MIP maps. So by this one, you're setting which one is default MIP map. So basically your LOD. So number one texture. And this number, this texture will load and will be always as your number one. And everything above that or below that, yeah, below that will be removed. So for example, it starts 0. So this is our highest resolution. If I will set it to 1, you see, it basically says imported 2K, but displayed and maximum in gain, it's 1K. So to the project size, this will contribute, yeah, or the upload size. But for the download, it will be counted as a 1K. So it will optimize. So this thing will optimize for the download size and on the rendering side. So it's basically, it helps your GPU because you don't need to sample so many now pixels. And more stuff you will have on the screen. more materials with more textures. It's basically lots and lots of sampling. Sampling of the texture, it's one of the slowest process in rendering. Yep. So keep that in mind. And there is nothing will tell you how long it will take sampling. So keep that in mind. So we in here, we can tell which texture size will be starting. But with maximum texture size, you can manually input number, and that will be as well. So basically use or one or another. And if you're not using MIP maps, then always use only this one. So if I will set 512, you see, now it will be 512. I can set 256, it will be 256. 124, 124. And with this maximum texture size, it helps us then cut this size to that size maximum we want. So again, in this case, I don't care about quality of the cliffs because I'm just showing how to optimize textures. What I'm usually doing, I'm coming close enough, yeah. So how I believe player can come, and here is basically trade-off. It's sacrifice a little bit quality for the memory size. So I'm playing with the numbers. So I'm dropping this maximum texture size, so like from 2K to 1K, sometimes 512. And if I see that, okay, I can live with that quality of the mesh, so I'm leaving that. So for example, in this case, what I will do, I will take all textures. So normally I wouldn't do this. I would, as I said, I will go one by one mesh and change texture. So it's not like all texture should be 1K or all texture should be 512. Some textures in my projects, they could be even 256. Sometimes they 1K, sometimes even 2K. So there's not like one rule for everything. But just in this case, so I'm selecting all of them, right click, action assets, edit selection in property matrix. So in here, I can again select all of them. Here it is, maximum texture size, because one texture already has changed and other not, so it shows multiple values, but I can set, let's say, 1024 for all of them. Will take a while to update. So now all of them will have 1024, and I can set, edit this padding, so stretched power of 2, and now save. So I saved. Now it will help my GPU because now it's 1K, right? And initially, don't forget, you see, if I will hover over the texture, in the middle, it says dimensions 4096 by 4096. This is original texture size I imported. And it's actually, it was showing me 2048 by 2048 because of UEFN. UEFN maximum allows that and it's reduced that. But my original dimension not changed. And that's why size it's huge. So now for the project size, it counts as a 4K. And you can see it's even higher. It says disk size 35 megabytes. It's crazy, and it's only one texture, right? But now we change this maximum texture size, and what we can do now is right click and resize texture import data. What it does, look, if I will hover over that and it now says dimensions 1024 by 1024, it basically reduces this way original, even imported texture into my maximum of this texture size. So now you see imported is 1K and displayed and maximum gain 1K. And texture size, it's 1365 kilobytes. Okay, so now let's push. So again, let's refresh and see. Yeah, you see it's still 13. It's definitely not 13. So it's not refreshing. So what I will do, I will push and I will pause until it pushes everything. Okay, it's pushed, and you straight away can see that project size now it's 6%. So it dropped by 7% just by doing what we did. And now biggest contributors, not textures, but our cliffs. And as I showed in first video of the series that you can go then into cliffs and optimize them. Yeah, you can see like it's 70,000 triangles, and you can reduce it here, and it will go even lower than in project size. So again, this is not entirely how you should work, so like selecting all textures and just reducing to one particular number, because it's based on how close player can come to the object, how big is the object, like for example these cliffs, and maybe you have cliff and maybe you have one small rock, so all based on the size and closeness to the camera. And yes, it takes basically longer because you need to go texture by texture, yeah, object by object. But this is how you can create really properly optimized project with really high quality, instead of like just cutting lots of these polygons and cutting lots of pixels from the texture and say, yeah, I've done a good job, but it will look basically crap, right? So you need to find the balance. So hopefully this covers most of the stuff what you needed, and hopefully this will help you to create more advanced maps in the future. Have fun. I would like to say thank you to my all supporters. I appreciate your support. Thank you for your generosity. You can join our growing Discord community, where we like to discuss UEFN tips and tricks, showcase our work, and help each other. You can find link in the description or in the channel header. You can get project files on my Patreon or just buy me a coffee to support me. If you're interested in learning more about UEFN materials, coding, widget UI, and more, feel free to subscribe and click that bell icon to get notifications when new videos will be released. See you soon.